So today's lesson is lesson 6.1b. So the first thing I want you to do is write down your I can statement. You're going to write down your I can statement. So using that green colored sheet for your unit 6, put down your I can statement, but I'm going to jump right into our notes. So today we're looking at using the power rules. The power rule of exponents. The basic rule is that you need to remember that you're distributing the power outside of the parenthesis to each item inside of the parenthesis. Also, remember if there's no exponent, you need to give the item a power of 1. Remember that when you distribute, you multiply. So for our first example, a power of a power, I have g to the 4th power raised to the power of 3. This becomes a multiply. 4 times 3 is 12. So this is equivalent to g to the 12th. Why does that work? Well, g to the 4th power raised to the power of the 3 is the same thing as g to the 4th times g to the 4th times g to the 4th. And we know from the product rule, you just add those exponents. 4 plus 4 is 8, plus 4 more is 12. You have the power of a product, a times b, both raised to the power of 5. Well, when I expand that, that just means ab times ab times ab times ab times AB. You have 1, 2, 3, 4, 5 A's being multiplied together. 1, 2, 3, 4, 5 B's being multiplied together. Using the power of a product rule, remember that A times B raised to the 5th power. Well, there's a 1 next to each one of those. Remember we talked about if it doesn't have an exponent, give it a power of 1. And when you distribute, remember you multiply. 1 times 5 is 5. And 1 times 5 is 5. So that's why that works. Our last one is the power of a quotient. 5 sevenths to the power of 3, well, that's 5 over 7 times 5 over 7 times 5 over 7, which equals 5 to the 1, 2, 3 power over 7 to the 3rd power. But when I use the quotient rule, I don't have to expand it, because remember that I can give each one of these numbers a power of 1. 3 times 1 is 3, so that gives me 5 to the 3rd over 3 times 1 is 3, 7 to the 3rd power. So we're distributing the power, remembering that if there is no exponent, we give it a power of 1. All right, so example 1a. I have 3 to the 5th raised to the power of 4. That's the same thing as saying 3 to the 5th times 4, right? We're distributing the power. Remember when we distribute, sorry about that, when we distribute, we multiply. So that equals 3 to the 20th. I can expand that just so you can see what it looks like. 3 to the 5th to the power of 4 is 3 to the 5th times 3 to the 5th times 3 to the 5th times 3 to the 5th. That's what that really means. And then again, using your product rule, you just have 5 plus 5 plus 5 plus 5, which equals 3 to the 20th. So 2 different ways to look at it. This is when I expand it and use the product rule. This is when I just distribute the power using the power rule. Example 1b, I have a quotient. So I'm going to use the quotient rule. 7 over 4. Remember that the 7 and the 4 are to the 1st power raised to the 2nd power. Well, I'm going to distribute that power. Use your little arrows to remind you to multiply. 1 times 2 is 2, so that gives me 7 squared over 2 times 1 is also 2 over 4 squared. You can also think of it as expanding it. 7 over 4, the quantity squared, well, that's just 7 over 4 times 7 over 4, which again equals 7 squared over 4 squared. This is power of a quotient. This is just expanding it using the product rule. Either way, you get the same answer. I want you to use whatever method works best for your brain. I am going to focus on the power rule. So whenever I have a power outside of a parenthesis, I distribute that power into the exponents inside of the parenthesis. Remember, when you distribute, you are essentially multiplying. So this becomes 8 to the 2 times 2 power. I said 8, I meant x, sorry. And y to the 3 times 2 power, which equals x to the 4th and y to the 6th. Example number 2 is going to have a couple of things going on. The first thing I want to do is I want to add a 1 on my y and a power of 1 on my x, because I want you to remember that even though there's no exponent inside the parenthesis, everything is, if there's not an exponent on it, it's to the power of 1. So I have x squared y divided by xy cubed, all the quantity raised to the power of 2. So that means that this 2, this power on the outside, is going to be distributed to each of the exponents on the inside. So this becomes x to the power of 2 times 2, y to the power of 1 times 2, over x to the power of 1 times 2, times y to the power of 3 times 2. So I'm going to simplify that first. So that is x to the 4th y squared over x squared y to the 6th. Now you can do this two different ways, but we're going to use our concept of the quotient rule that says if the bases are the same, you can subtract the exponents. So this becomes x to the 4 minus 2, and this becomes y to the 2 minus 6. That equals x squared y to the negative 4. I don't know if you realized from the homework assignment that you did yesterday, we actually take negative exponents and drop them down and make them positive. So this is really x squared over y to the 4th. Your lesson on negative exponents is really tomorrow, so I would accept either answer until your lesson for tomorrow. So here I have 3d squared c cubed over 6cd, all raised to the power of 2. So here's the first time that we actually have some coefficients. Even the coefficients, not just the variable terms, but even the coefficients are to the power of 1. So I'm distributing this 2 into every single exponent. So I'm going to rewrite it first. So 3 to the 1 times 2 power is 2. D to the 2 times 2 power is 4. And C to the 3 times 2 power is 6. Over 6 to the 1 times 2 power is 2. C to the 1 times 2 power is 2. And D to the 1 times 2 power is also 2. I'm going to simplify my two coefficients. 3 squared is 9, and 6 squared is 36. I have d to the 4th minus 2. Remember, I'm going to use the quotient rule, 4 minus 2, and c to the power of 6 minus 2. So moving over, I'm also going to simplify my 9 over 36. I know that 9 goes into itself one time and 9 goes into 36 4 times. So I have 1 over 4, but I have to take care of my variable terms. 4 minus 2, that gives me d squared. 6 minus 2, that gives me c to the 4th. Alrighty, this next example looks a little tricky, but remember that we're just multiplying. So the first thing I'm going to do is take this 2 on the outside power and multiply it by the power on the inside. 2 times 2 is 4. So I'm going to rewrite this as 2 x squared y cubed all over 5 all to the power of 4. All to the power of 4. I'm going to add my exponents on my coefficients, 2 to the first, 5 to the first. And now I'm going to distribute that power of 4 to everything inside my parenthesis. So that leaves me with 2 to the 4th power, x to the, well, 2 times 4 is 8 power, y to the 3 times 4 is y to the 12th power, over 5 to the 1 times 4 is 5 to the 4th power. Now I'm actually going to simplify the 2 to the 4th and the 5 to the 4th. 2 to the 4th is 16, so I have 16 x to the 8th, y squared, y to the 12th over, let's see, 5 to the 4th power, that's just the same thing as 25 times 25, which is 625. Okay, let's look at example 4a. So again, I have some coefficients with no exponents. We're going to give those a power of 1 and these two variables down here. And I'm just going to distribute my power. So I'm going to multiply every exponent on the inside by 2, because that's my power on the outside. So that leaves me with 4 squared, d to the 4th, c to the 6th, over 8 squared times c squared times d squared. When I simplify this, I get 16 d to the 4 minus 2, c to the 6 minus 2, over 64. That's what 8 squared is. And 16 will go into itself one time, and we'll go into 64 4 times. So I actually get d to the 4 minus 2, which is d squared, c to the 6 minus 2, which is c to the 4th, all over 4. Now I want to do this problem a different way, and I want to show you that you can always simplify. Remember that these are fractions. So if you can simplify first before you distribute that power, go ahead and do it. So I'm going to kind of draw a little arrow here, and I'm going to write a little note that says I'm going to simplify first. This is an example of me simplifying my fraction first. 4 will go into itself one time, and 4 will go into 8 2 times. D squared divided by d just leaves me with a d. So that exponent goes away. It's just to the first power. C cubed divided by c to the first power makes this a power of 2. So I'm going to show you that over here. So I have 4d squared c cubed over 8cd. So again, 4 cancels out, or 4 goes into itself one time, 4 goes into 8 2 times. 2 minus 1 is 1. 3 minus 1 is 2. Now I can distribute that power of 2. So 1 times 2 is 2, so that gives me d squared. 2 times 2 is 4, that gives me c to the 4th, over 2 squared, which is 4. So same exact answer. It just depends on which method you want to use, which method works best for your brain. I try to typically simplify my fractions first. So here I know that 4 divided by 2 is just a 2. So I'm going to turn this into a 2 before I cube it. So I really have negative 2 to the 3rd power, and x to the 2 times 3 is 6 power. That's over 1. Multiplied by 2 times 2, like 2 squared, x squared, over x to the 6th. So let's see, negative 2 times negative 2 is a positive 4, times negative 2 is negative 8 x to the 6th times 2 squared is 4 x squared all over 1 times x to the 6th is just x to the 6th. And then hopefully you see that you have x to the 6th power in the numerator, x to the 6th power in the denominator. So those cancel out. You have a denominator of 1. So this means that this is going to be some kind of integer. Negative 8 times 4 is negative 32 x squared. It's all over 1, so you just don't even need to write that. Okay, so this one looks a little bit interesting, and I know that you're thinking, oh my gosh, what has happened? Well, remember the quotient rule. The quotient rule says if the base is the same, you just subtract the exponents. So what does that mean? Well, my base is the same, so that means that I have 4 to the power of x plus 3 minus the quantity 2x minus 1. That's really what's happening. But I have to distribute this because I'm subtracting the whole quantity of the denominator. So that really gives me 4 to the power of x plus 3. Negative 1 times 2 is negative 2. So that gives me negative 2x. And negative 1 times negative 1 is plus 1. And now I can simplify that. So that gives me 4 to the power of, I'm going to combine like terms, 1x minus 2x is negative x. And 3 plus 1 is 4. I know it looks a little weird, but that's how that works, okay? So, again, another weird one, we have an expression. We have an algebraic expression representing our exponent. So remember that this power just gets distributed, right? It's getting distributed to the exponent. So this is the same thing as 5 to the power of 2 times 2x plus 6, because that's our whole exponent, over 5 to the power of 2 times 3x minus 4. So let's simplify that first. So I know I have a 5. 2 times 2x is 4x. And 2 times 6 is plus 12. Over 5 to the power of 2 times 3x is 6x. And 2 times negative 4 is negative 8. So now I'm going to use the rule that says if the base is the same, I can just subtract the exponents. My numerator exponent, 4x plus 12, minus the quantity of 6x minus 8. Now again, I have a negative outside of my parentheses, so I have to distribute that. So let's simplify that one step further. 5 to the 4x plus 12. A negative 1 times 6x is minus 6x. A negative 1 times a negative 8 is plus 8. So then I'm going to combine my like terms. That equals 5 to the power of, let's see, 4x minus 6x is negative 2x. And a positive 12 and a positive 8 is plus 20. So your final answer is 5 to the power of negative 2x plus 20. Okay, so it's just a different way to look at it. I know that those expressions as exponents look scary, but the operations still work the same. It's the same rule.